these two sections, like I said, this is a calculator section. If there's a calculator section in your book, it's 4.1 and 4.2. So, and I try to make it, I don't make it a difficult test. So you got a good chance to make 100 on this test. And it's going to be short and sweet too. All right, so your family of graphs. You got your linear. F of x is equal to x to the first power. That's a linear. And y'all got this, because while I'm going over this, go get your family of graphs note page that I told you to do so you can update it. You've got your parabola squared function. F of x is equal to x squared. You've got your x to the third function. And here we're going to put the quartic functions, which means I'm going to draw two lines like that, but I'm going to draw a more squared bottom. And that is f of x is equal to x to the even power. And then f of x is equal to x to the odd power. It's going to flatten out. Well, I messed that up. It's going to flatten out more here, and I'll get to that in just a minute. F of x, oops, I don't know what I just did there. Sorry about that. F of x is equal to the square root of x. F of x is equal to the absolute value of x. F of x, I don't know why I keep wanting to put f of x up there. F of x is equal to 1 over x, which is what we're going over today. Oh gosh, I just messed that up. And f of x is equal to 1 over x squared. Okay, now whatever you've got in whatever order is fine, but the reason I'm bringing this back up is because you need to add what we're going over today. You need to add, if we've already covered it, that's fine, but you need to add those two, and we're going to get to that in just a second. Okay, I also wanted to bring up ending behavior. When you have a x to the second power or a x to the even power, your ending behavior is going to be two arrows going in the same direction. And that's called ending behavior. That's pink. I'm going to write in pink up at the top, ending behavior. Ending behavior, you will be asked this on a test and a standardized test. If they give you a function, f of x is equal to x to the 27th power, well, that's an odd function. So it's going to look like ending behavior like an odd function. And I'm going to do that in another color. Let's go with orange. With an odd function, the ending behavior is going to be opposite directions. Okay, so the first thing that you're going to be asked in 4.1 is about ending behavior. Okay. Now, the second thing you're going to be talked about is kind of like hidden behavior. Now, as I told you, when you have an odd or even function, the higher, the more this flattens out, and the more this right here flattens out. So I'm going to take my blue marker, and I'm going to highlight this area right in here. And this area right in here. The bigger the exponent, the more this is going to flare out and square out, and the more this is going to flatten out. Almost to the effect that you might see a kind of a dip here, or you might see a little bit of a saddle here. Okay, so this will transform into a saddle type shape for both of these. Now, what am I talking about, a saddle? Well, I'm just going to go to the next page. We're going to come back to this one in just a second. A saddle is where you've got a dip. You can have a saddle with a even function that looks something like this. Okay, and there's the saddle right here. You could have this function, which is an odd function, and here's the saddle right here. A saddle is when you have local min and local max, and then true min and true max, which you've got several different ones. Over here, I've got a min and a min and a max. Here, I've got a max and a min. Okay, so those are some words that you should know from pre-algebra, not algebra, but algebra 1 or 2 or 101, 102. Make sure you know the difference. A max, a min, and a min. This is a max, and this is a min. All this is going to be done on the calculator too, so you really don't have to do anything as far as mathematics. You just need to know how to use your calculator. All right. So when your functions, when these two functions right here, an even or an odd function, when they start getting higher and higher, let's show you what happens. I just dropped my pen. Let's say you have an x to the fifth function. F of x is equal to x to the fifth. Well, then you could have down here, you could have a fourth, a third, a second, and a first. Okay? You got your primary, your leading function, your leading term is a fifth degree. So this is a fifth degree polynomial. And that means it could have every one of these, or it could have some of them, or it could have all the way down to, you know, x to the 0. Okay? I'm going to put x there, x there, x here, x here. So this one could have all kind of things going on. We know it's an odd function, so it'll have ending behavior, but it could have a little dip like that in here. The x to the fifth says that you've got arrows going in opposite directions. And since this is high up and you've got these functions in here also, that's what gives you this. All of this right here gives you that right there. So depending on what you've got behind that x to the fifth, determines how much of a saddle you have right in here. And some of them can go like this. It can be real, extravagant, depending on whatever you give it. So make sure, and they go through and tell you that a local max, and then you got absolute or true max. The difference between an absolute max and a true max, or a true min, or when you have a local min or max, that means you've got an absolute max, min or max somewhere also. I like to tell students, this is the primary max or min, and this is the secondary. So if you got a max, x is equal to, let's say, let's do something like this. Let's go with let's go with something that looks like this. Okay, I've got a min right here, and I've got a min right here. And let me color this one pink. And let me color this one green. Somebody tell me which one is the absolute min. The green, thank you. Absolute means the primary, the one that holds the most weight. And in this case, the min that holds the most weight is this one. So this one's primary, this one's secondary. That's the way I tell students to discern which one's which. Now, we don't have a local max, we just have an absolute max. And here is the absolute max, because there is no other max to compare with it. Okay, so make sure, one, you know your parent graphs. Two, you recognize ending behavior, which is same direction and opposite direction. Same direction, opposite direction. X to the even power is the same direction. X to the odd power is opposite directions. That's number one on the test. On standardized test, make sure you know it. The second thing you need to realize is that you also have, as the exponents get higher and higher of the lead term, as they get higher, you've got more room for hidden behavior. And that hidden behavior falls in the saddle part of the function. And you got to make sure you know how to find the local min, local max, absolute min, absolute max. And the local min, that's secondary to the primary, which is the absolute. So let's go to our handy dandy calculator, because we need to talk about how to do some of these things. So I'm going to go to my handy dandy calculator, and I'm going to erase everything that's in my y is equal. And I'm going to go ahead and do x is equal, y to the first is equal to, or y sub 1 is equal to, let's go with x to the fifth x to the 5th plus, well, sometimes I do not like these calculators, plus 2x to the 4th plus or minus 3x to the 3rd minus 2x squared plus 3x minus 2. And graph. Okay, so I can't see anything, so I'm going to hit zoom standard. Look at there. You got all kinds of funky things going on. So I'm going to do zoom. I use zoom box, okay, because it's short and sweet. And I'm going to go up to the top, and if you can see my cursor, it's right up there at the top. I'm going to go out. There we go. I'm going to enclose all the turning points. Hit enter. Now, some of y'all might not know about this feature, but I use it all the time. There we go. And I hit enter. And you can use the window. That's fine. I don't care. So we've got a function that looks like that. So I'm going to draw that over here with my handy dandy do jigger. There's also something else I want to show you. Let me go back to the function. Let's see. Well, y equal to f of x is equal to x to the 5th plus 2x to the 4th minus 3x to the 3rd minus 2 minus 2x squared plus 3x minus 2. Okay, some things we can tell about this problem from the get-go. Invalid dimension. You must be typing in one of the subtraction symbols wrong. Don't use this down here unless you're putting it in front of a negative number, okay? Use this subtraction symbol. That's the only other thing I can say. Check, make sure you hadn't messed up one of your exponents. I'll get to that in just a minute. Okay, 2 or 3 things before we even graph it. Number 1, the leading term is x to the 5th. Therefore, this is a 5th degree polynomial. Okay. So the first thing you do is look at it and say 5th degree polynomial. The second thing you say, the leading coefficient is 1 because the leading, so 2, the leading coefficient is equal to 1 because that's the coefficient of the leading term. Now, since the leading term is to the 5th power, that means it's odd. x of 5th degree equals odd. Therefore, your arrows are going to look like this, going in opposite directions. And you should be able to sketch a graph on it by using your calculator. And we look like going up, going down, like that. We also know, number 4, the leading exponent, 5 minus 1, using n minus, tells us how many turns it has. So 4 turns. 1, 2, 3, 4. 4 turns. Now, all of that you should have seen. Your screen is frozen for me, and you're cutting out. I'm moving. Okay, Miss Davis, are you still here with me? That's Miss Davis.
I'm here, but I don't, it's frozen for me too.
Okay, well, I don't know what to tell you, because I'm moving. Let me send it again. I'm going to send another present screen and tell me if y'all see it change. All right, right now I'm sending another print screen. And y'all let me know what happens.
It's moving for me now. It's just a little laggy, so it takes a minute to catch up.
Something must be going on with my internet. I'm sorry. I thought I rebooted it. I have to reboot it for the next class. I turned everything on when I got here, so I don't know. I'm sorry. Now, all of this stuff that I wrote down right here, this should be kind of a review-ish for you. You may not have gone into it a lot with the previous class, but you should have heard about some of this stuff. Okay, now we're going to go and do the trace feature. We're going to find all kinds of good things with the trace feature. It's second trace, and you can find the zeros, which means your x-intercepts. Find the min, max, and if it intersects anything. Now we don't have 2 lines, so you don't have to use intersect. But you can go to 0 and let's find left bound. I'm going to go to the first x-intercept, which is over here far left. And it says find the left-hand side. Okay, there's the left-hand side. Right-hand side is right there. And then a guess, I guess the closest I can get is there. And there is my left x-intercept, 2.65. So I can label, and I'm going to put stuff that I found on the calculator. I'm going to do it in a green color. So I found this x-intercept right here, and that's negative 2.65. Negative 2.65. Now I'm going to find this x-intercept. Let me hit the focus button. That's a little bit blurry. Yeah, my computer's freezing up now. All right, that's about the best I can get it as far as focus goes. All right, so this next one, I'm going to hit second, trace, 0. Then I'm going to go find the other one. Left bound would be right above the x-axis. Right bound would be right below the x-axis. And my guess would be right there. And that's negative 1.36. So this is negative 1.36. Now I'm going to find this x-intercept. So second, trace. And I'm going to find the right intercept. So my left hand would be right about there. My right boundary would be right about there. You don't have to, it just makes the computer speed up if you give it a short area to look. And that x-intercept is 1.18. Now you can find the y-intercept by plugging in 0. And when you plug in 0, everything goes out except for -2. So you know that that is -2 as far as a y-intercept. So what's next? Well, then you got to find your local min and your max and all that. Excuse me. Ooh. So I've got 2 local mins and 2 local maxes. Well, I got 2 mins and 2 maxes. So this is my true max, and this would be my secondary max. And then in another color, let's go with orange. This is my primary min, and this is my secondary min. Okay, so now we're going to find the max and the min. So second, trace, max. And I'm just going to tell you, it really don't matter which one you pick. Since the calculator uses the same program, it's going to tell you what the vertex is, whether you ask for the min or the max. It's going to tell you. That's the right-hand side. And my guess right in there. So that min, or that max, is negative 2.19. Excuse me. Negative 2.19, comma, 8.98. There's one max. Now let's go find the other max. I wrote in the wrong color. I'm supposed to write in the turquoise color or blue. Sorry. 2.19, 8.98. Okay, now I'm going to find this one right here. So second, trace, second, trace, max. And I'm going to go over here. And my left is right in there. My right is right in there. And your local max is 0.51. 0.51. Using the wrong color. 0.51, comma, negative 1.21. Negative 1.21. Okay. So now I'm going to find my local mins. So second trace, min, and I'm going to try to get it. It's a little bit off the screen, but I'm going to try to get it. My left will be right in there. My right will be right in there. My guess would be right in there. And that's going to be negative 0.69, negative 0.69, and negative 3.7. And that is my absolute max, min. Now I'm going to find number 4 right here. So second trace and min. And I'm going to go over here and put a left right about there. Put a right about there. And my secondary min would be right there. 0.77 and negative 1.3. Now, of course, I'm all over the place with rounding decimals, but I'm not worried about you rounding decimals. Y'all can follow the directions. I'm just showing you how to use the calculator and find what you need to find. Now, I can tell you right now, out of 4.1, this is pretty much your standard test questions. Okay, I'm going to ask you all of this stuff. That's what I'm going to ask you. Nothing else. That's it. So you should be able to ace 4.1. Okay, let me look and see what else we got in 4.1. I got my notes written down here. Yeah, because the only thing left in 4.2 is long division. And that's a little bit of math, but excuse me. Oh, so you should be able to graph a graph, and you should be able to tell me everything about that graph using your calculator. All right, let's do a nerd. See if I can find one on the homework. Oh, let's see, assignments 4.1. Of course, I haven't done it yet, so I'm going to do that right now. There we go. All right, try that one. And we're going to find everything we can just by going through the motions of f of x is equal to x to the third minus 3x squared minus 6x plus 12. Well, from the get-go, I know my y-intercept is 0, 12. I know that we have two terms because 3 minus 2, 3 minus 1 is 2. And I know we have opposite ends as far as ending behavior. And let's see, can I tell anything else? Probably not. Now, since we know that 1 is in the first quadrant and 1 is in the third quadrant, we know that B is not the answer. We know that C is not the answer. So without even graphing anything, I know the answer is probably A. See, I just got that answered. I didn't even do any math. Okay, what else do we know? Well, we're going to have to graph it. Let's graph it. Looks like it's got hidden behavior. So let's go ahead and graph it. And I know I answered the question, but if you can do everything that I do, then you're okay for the test as far as 4.1. So y is equal to x cubed. Let me go ahead and delete everything just to get clear. Okay, so x to the third minus 3x squared minus 3x squared minus 6x. I hate these calculators. Of course, it doesn't have anything to do with the operator, right? Okay, minus 6x plus 12. Zoom, standard. And look at there, we got something looking crazy. All right, but our generalizations are true. Okay, we probably got a y-intercept of 12. We know it has two terms, one at the top left, one at the bottom right, and opposite directions as far as the ending behavior. So we got all of that. We haven't even graphed anything. That's pretty good. Let's see what else we can find. Well, let's go ahead and find let me zoom back a little bit. I'm going to zoom out. I might have to zoom back in. Okay, there's my terms. I'm going to hit zoom box. I'm going to go to the top left of that turn. And go down, cover the bottom turn. Now we've got a min and a max. So I'm going to hit second trace. And I'm going to go to the max. Left. Right. And center. negative 0.73. So we've got a negative 0.73, negative 0.73, comma, 14.4. And now we're going to find the min. Second, trace, min, left bound, right bound, (2.7), comma, negative 6.4. And see, you have just told me everything I need to know about this function. How about domain? Well, it's got arrows on it. It's to the third power. There's no fractions or no radicals. So domain is all real numbers. Range, negative infinity to positive infinity. And increasing from negative infinity to negative 0.73. Decreasing, well, I'm going to put all the increasing in at one time. So increasing from 2.7 to negative 6 point, I'm sorry, to infinity. Decreasing from negative 0.73 to 2.7. Again, if you can tell me all of that, then you're good for the test as far as 4.1 goes. 4.2 is just going to be long division. So we'll go over that Wednesday. So probably talking about a test Friday, in which it's only going to be like 10 questions. And I can tell you right now, 4 or 5 of them are going to be this, and 4 or 5 are going to be long division. So it's not like it's going to be rocket science or anything. I mean, pretty simple, pretty standard review. Because a lot of y'all did this in 101 or 102. May not have gone into it as in depth. Questions? Okay. That's class for today. Let me go ahead and stop the presentation so I can take the roll and stop the recording. Okay, somebody make sure Mr. Cash is here, or I record Mr. Cash is here.